the first thing that we have is the magnetic flux. Magnetic flux is equal to magnetic field into area. When you have the angle, you will use BA cos theta, provided that this theta is basically the angle between area vector and the magnetic field. Okay, not with the plane surface. So whatever you have, let's say we have this plane surface with us. So magnetic field is present. And if we drop an area vector over here, so this theta is what you'll have to consider in this. That is the flux. So this is magnetic flux. Phi is equal to B dot A. Phi is BA cos theta. And apart from it, if you have a variable magnetic field, you can use B dot dA, integrating it. Okay, whatever is the area given to you. Area 1 to area. Use this formula when you have a variable. When your magnetic field is variable. In the sense, you have some equation with respect to time, with respect to area, like this, the equation is present. Okay, so phi is equal to B dot integral of B dot dA. You can use integral of B dot A. This is one point. And for magnetic flux, see, you will only have to consider that those number of field lines that are perpendicular to the surface. Perpendicular to the surface. Okay, means only those lines should be considered that are making an angle of 90 degrees, like this. This is the magnetic field line, which is perpendicular 90 degrees. This is a magnetic field, which is perpendicular. Like this. This is the magnetic field that is perpendicular, like this. All these are making an angle of 90 degrees, and these are also, when you if you'll have to find the final flux, you will say the flux is 3 over here, like this. Okay, so these are the number of field lines that are present about the magnetic flux. Then you have the Faraday's law. That is also equally important here, the next topic that comes. When we talk about the Faraday's law, in Faraday's law, you use the equation E is equal to minus d phi over dt. So two things occur. EMF, this is directly proportional to rate of change of flux. Rate of change of flux. Okay, and second is about regarding the negative sign. Negative sign basically tells us, this negative sign will only tell us about this will tell us about the Lenz's law. When we talk about the Lenz's law basically says that whatever will be the direction of induced current, it actually helps us deciding the direction of induced current. Direction of induced current. So direction of induced current is such that it opposes its cause that produces. Its cause that produces it. Now we know when we refer to this cause, cause is basically the changing magnetic flux. This is the changing magnetic flux. Now see, if you're confused about the changing magnetic flux, what you can do? You can refer to see, you can refer and check whether the magnetic field is changing or not. So this is changing magnetic field. Okay, so first you'll have to go in this sequence and you check whether magnetic field is changing or not. If magnetic field is changing, then you see the flux. If flux has been changed, then you see the induced current or the induced EMI. Okay, so this is the way you have to see. And few questions let's discuss. Meanwhile, you write.
Ma'am, can you scroll? Ma'am, can you scroll? Done, ma'am.
See, this is magnetic flux is given by the equation of flux is 5t square plus 3t plus 16. This much in Webers, that's the unit of it. So in Webers, it's given. It says magnitude of induced EMF in the coil at the fourth second will be. Means you have to find out at t is equal to 4 seconds. At the fourth second, what will be the value of the EMF? So for that, you need to find out the equation of EMF. So we know E is equal to minus d phi over dt, right? So when you differentiate it, minus of, you have to differentiate this entire term. 5t square plus 3t plus 16. So this is equal to 10t plus 3. This is equal to 10t plus 3. This much of volt. Now, when do you have to calculate it? You have to calculate it at 4 seconds, right? So see, put at t is equal to 4 seconds. E will be minus of 10 into 4 plus 3. That is equal to 40 plus 3, which is minus 43 volt. Now we know minus sign is for the Lenz's law. 43 is its magnitude, and the question has given us only the magnitudes as the options. So this will be correct. Here, B, 43 volt will be the answer. Okay, write it. This is a question from 2020's paper. Please write it.
Ma'am, can you scroll?
Okay, see this question. This says that a conducting circular loop is placed in a uniform magnetic field, and this is the magnetic field B is equal to 0.025 Tesla with its plane perpendicular to the loop. This is the loop and the magnetic field, they are perpendicular to each other. The radius of the loop is made to shrink at a constant rate of 1 millimeter per second. It's a very important question. Though it's a very previous question long time back, AIPMT 2010, but this question will help you understand the concept. This says that the radius of the loop is made to shrink at a rate of 1 millimeter per second. This means the radius, let's see, the millimeter is the unit of the length. So radius per time, dr over dt is given as 1 millimeter per second. Okay, that is given as 1 millimeter, which you can say 10 to the power minus 3 meter. Meter per second actually. 1 millimeter is given. And radius of this radius is given as 2 centimeter, which is 2 into 10 to the power minus 2 meter. Now, see, when we have the flux, we know flux is equal to B dot A. Now, area, this is a circle which is present. Here, R is there. So, area of the circle is pi R square. Let's put it. When you put this, flux will be equal to B into pi R square. Okay, and here EMF will be equal to minus d phi over dt. Minus C d over dt of B pi R square. See, B will come out, I will come out. This is the magnetic field, minus sign. Now see, R square is left. So when you differentiate, you get 2R and this dr over dt is left here. 2R comes out because of differentiation and dr over dt is left. So what do we get here? Minus magnetic field. Magnetic field is given to us 0.025. 0.025 into this is pi, which is 3.14 into 2 into the radius is 2 centimeter, 2 into 10 to the power minus 2, and rate is given as 1 millimeter, that is 10 to the power minus 3. All of these equal to the voltage. Okay, all of these equal to the voltage. This much. So this you have to solve and check which option out of all these is matching. What kind of options are given? Okay, so in pi you don't have to solve. Don't solve pi because the question gave the answer in as 3.14. This is pi. Micro also you have to take out from here. So this is 10 to the power, this is 10 to the power minus 5 already. From here you'll have to take, this is 4. So 200 will be 25 into 4 will be 200. So 2 pi something, this will come out. Write it, see which option is matching. Okay, Jesslyn, see. This says a circular disc of radius 0.2 meter is placed in a uniform magnetic field of induction 1 by pi Weber per meter square in such a way that its axis makes an angle of 60 degree with the magnetic field. The magnetic flux linked with the disc is, what's the magnetic flux that is linked with the disc? The radius is given as 0.2 meter, and this says magnetic field induction. That is magnetic field. Look at the unit. It says uniform magnetic field of induction. Weber per meter square is given to us. Means Weber is for the flux divided by area. Okay, this is Weber per unit area is given to us as 1 by pi. Weber per meter square, in such a way that its axis makes an angle of 60 degree with magnetic field. Theta is 60 degree that it makes with the magnetic field. Magnetic flux linked with the disk is, see, here magnetic field by area is given to us. Look, this is also a good question, though it's a very old question. Flux will be equal to area multiplied to 1 by pi. Now, area is what? This is a circular disc. Radius is given. So, area is equal to pi r square. That is 3.14. Radius is 0.2 whole square. So, flux is equal to 3.14 into 0.2 whole square divided by pi. Pi will be cancelled. This is 0.2 whole square. So this will be 0 is given only for this. Okay, angle is also there, 60 degree. This is not 0 degree, 60 degree. So see, BA cos theta means you'll have to include 60 degree as well. That is, see here B dot A. When we write no flux as B dot A, look. When the flux is written as B dot A, this is B A cos 60 degree. But it is seen here we have BA cos 60 degree. Now 60 degree is given to us. So magnetic field 1 by pi, you'll have to multiply the whole thing with cos 60 degree as well. So whatever we have got, I forgot to multiply it with this half. So here cos 60 degree will be half. So that will give us 1 by pi into, what was it? Area was 3.14. That is pi only. I should write it as pi. Pi r square into half. Pi will be cancelled. This will be 0.2 into 0.2 divided by 2. This becomes 0.1, which is equal to 0.02 Webers. This will be the answer. Now clear, just think. Here I didn't multiply it with half. That's why options weren't matching. This will be 0.02, A option. Clear?
Yes, ma'am.
Okay, right.